in your day-to-day job? Okay, personal. Personal plus job, without letting your manager know that you are using ChatGPT. Okay, so how many of you are developing something to do with Gen AI, like consuming OpenAI or Azure OpenAI? Okay, very few. In the current set of audiences, I think I saw only 4 hands. How many of you are familiar with this term called RAG, Retrieval Augmented Generation? Just 1, 2, 3. Okay, so 4 are using the APIs, 3 are using RAG. Okay, so if you are actually following the tech landscape, you would have noticed there is a tremendous hype, tremendous buzz around generative AI, right? And today, generative AI is predominantly exposed through large language models, which are like GPT-4, or multimodal, like GPT-4o and Gemini. So these models are so massive and so resource hungry that they can be hosted only by a select set of cloud providers or infrastructure providers. That's the reason why today these models are available only through players like Azure, Microsoft Azure OpenAI, or Google Cloud Vertex AI, or Amazon Bedrock. And then there are some highly niche specialized startups like Runpod, Replicate, Fireworks, and other inference as a service providers. Now, what this actually means is these models require such a massive infrastructure that it is very, very difficult to run on premises. But that is going to change with the increase in the adoption of generative AI. Currently, as I was discussing, the entire landscape is more like, let's do a proof of concept, let's figure out what it really means before we invest anything. So today, consuming GPT-4 or Gemini or any of these multimodal AI models is very simple, very easy. You don't even need to spend thousands of dollars. For a few hundreds of dollars, you can actually build very powerful, very meaningful applications. But the challenge comes in when you are going to move it over to on-prem or in a private data center environment. Now, the biggest challenge for that is the availability or the lack of availability of GPUs. So the models, these large language models, also called as foundation models, require multiple cores, some tens of thousands of cores, to parallelly process the incoming task, which is actually called inference. And that is only possible when you have a GPU. And those GPUs are in acute shortage. Today, if you place an order for a GPU that is capable of running an open model like Llama 3, you need to wait at least. Check. Okay. Okay. Yeah. So if you want to run an open model like Llama 3 inside your data center, you need to invest in a A100 minimum 40 GB GPU. And if you place an order today with NVIDIA, it's going to take 8 months for you to get the GPU. And only then you can start putting that to use. So with this acute shortage of GPUs, we're not seeing enough traction or enough adoption of LLMs or foundation models on-prem. But that's going to change with some of the other dynamics. For example, the shortage of NVIDIA GPUs is leading to the rise of other GPU hardware providers. For example, a few months from now, we'll see AMD becoming very prominent, we'll see Intel becoming very prominent, and of course, Qualcomm offering more and more GPUs. And the models will also get optimized for this new breed of GPUs. And they're going to cost much less, because when the demand supply is met sufficiently, the prices are going to come down, and that's going to change the entire market dynamics. And that's when we are actually going to see tremendous increase in running Gen AI on-prem. And when it comes to running Gen AI on-prem, what is better than Kubernetes to orchestrate and to run these highly parallelized, compute-intensive workloads. So when customers run GenAI on-prem using Kubernetes, what do they use it for? Well, they are going to build internal chatbots. For example, a lot of employee HR support systems, onboarding systems, payroll support, IT help desk, whatever you are currently dealing with through a manual process, a manual workflow, is going to be highly automated and AI driven. So a lot of interactions that you have with your HR, with your IT, with your internal processes like travel desk, transport desk, all of that is going to be replaced by GenAI assistants. And we are not very far from that. We are maybe about 12 to 18 months before we actually see that happening very actively in the enterprise. So the demo that I want to show you today is a sneak peek of how cloud native infrastructure would power the emerging GenAI workloads. End of the day, generative AI workload is like any other stateless plus stateful workload combination. Here the statefulness comes from the data because that is the ground truth, which is going to hold your actual factual data. And then the LLMs, which are very stateless. So just like today you build applications, microservices-based applications that are talking to databases which are stateful, and there are highly stateless and horizontally scalable applications, GenAI workloads are going to be very similar. The statefulness comes from data and models. The statelessness comes from the agent infrastructure or the chatbots and some of the other things that are surrounding these models and data. So that's what I want to show you. So I'm going to use a technique called RAG. Can I have my laptop? Yeah. So this is the demo environment that I have. So I'm going to build a fictitious application for a fictitious airlines company. So the idea is to build a chatbot, and this chatbot will be powered by an open model from Mistral, and the data is stored in a vector database called Chroma. And as soon as I add data to a MinIO bucket, I use event-driven architecture to trigger a webhook, and this webhook will convert the PDF into a set of vectors which the chatbot can use to perform a search. And the embeddings model basically converts the PDF into searchable semantic context that will be used by our model. So at a very high level, this is the architecture of most of the RAG implementations, retrieval augmented generations. Because when you talk to a large language model, it may not be able to respond to your organization specific question. But if you feed enough context, it will be able to respond. So the whole idea is, how do we feed this context by grabbing it from an existing database and attaching that to the prompt so that the chatbot has visibility into the factual data and it can respond with exact answers. So that is what I'm going to build. Now, this is going to be a slightly tricky demo. In case this doesn't work, I have to explain you visually and verbally. So I'm going to VPN into my lab, which is in Financial District about 5 kilometers from here. So I'm going to SSH into my lab and show you a GPU cluster. Now, if you're wondering, why should I do that? Why should I take such a huge risk? The problem is, even if I'm willing to pay, I'm not able to get GPUs in the cloud. It is very, very difficult for me to build a GPU cluster in the cloud. I tried Azure, Google Cloud, Amazon, IBM, Oracle. I cannot get hold of a GPU every time I want. The only other option is I have to make a reserved instance where I have to pay upfront for the next 1 year. And that is very, very expensive, and I don't think I am ready to do that. So instead of depending on the cloud providers, I decided to build my own rig. So I have a cluster that is running multiple GPUs. I have 6 GPUs and a 3-node cluster. But to keep it simple, I manage each of those machines as a single node cluster. And occasionally I use it as a 3-node cluster. So bottom line, I have my own GenAI infrastructure running in my lab. So let me make sure I'm connected. Yes, this is working. So now I'm going to SSH into my lab machine, and I'll show you the configuration. You're able to see the screen? Okay, great. So first things first, I have two GPUs, which are the GeForce RTX 4090. It comes with 24 GB of VRAM. I have two of them. It's very unusual for you to see two GPUs connected to a machine. You typically get only one. It's very difficult because these GPUs are so huge that you cannot plug them into two PCI slots. So you have to hack the chassis to make sure that you are able to plug two PCIe GPU cards into the slots. So I have two GPUs, and if you look at my CPU configuration, I have a 32-core Intel CPU. So this is very high-end, very powerful CPU. And then if you look at my RAM, I have 128 GB of RAM, and I have roughly 4 terabytes of storage. That is just one node. I have 3 more nodes with very similar configuration. But I am currently using them as 3 independent clusters, because on one I perform inference, on one I fine tune, the other one I use for exploring and playing around with new models. So I'm currently showing you a test bed which I typically use for inference. All right, so that is my hardware, right? And now I can access this from my local machine. My kube config is pointing to my lab, so I should be able to access this test bed. It's called the GenAI test bed. So I think I have. Yeah, so my goal is to basically show you a chatbot that works based on this architecture. So this chatbot belongs to a fictitious airlines application. So let's go ahead and look at that. So I have a set of manifests. So I'm going to deploy each of them and then show you how they actually work. So the first one that I'm going to start with is obviously the namespace. So I'm going to create the namespace first. Okay. So let me start with the very fundamental unit, which is the namespace. And after that, I'm going to go through the next one, which is going to be my config map. So the config map basically holds the endpoints, some of the cluster IP names that I'm actually using it. So since it's a demo, I'm not protecting a lot of these endpoints, but ideally they need to be put in a vault or at least a secrets manager. But this is only for the demo. Oops. I think my network connectivity is a big issue. Yeah.
You can try connecting to this. Live innovation.
Okay, can we have the screen? Yeah. Okay, so I had trouble with the connectivity, so now this should work. So now the namespace is created, then I'm going to create the config map, which is going to create all these entries. And once we have the config map created, I'm going to launch my LLM. So let's take a look at the LLM spec. So the LLM basically runs on a local storage PVC. The reason why I'm doing that is these models are pretty large and I don't want the pod to pull these images every time. So what I do is I actually use it on my host. So for example, If you look at my host OPT data, within that I have a Hugging Face hub directory, and I have all the models that I typically use available on the host machine. So instead of pulling this every time I launch the pod, I simply point my pod volume to this directory. So that's the reason why I create a local storage. The other technique that I use is I have a 10 terabyte NAS. I typically store all the models on the NAS, and I use an NFS provisioner to mount the NFS into my pod, so I can avoid downloading these models repeatedly, because these models are so big that if I start pulling it before you, it will be done by tomorrow. So I don't want to do that. So these models are cached. So what I do is I basically mount this directory into my pod, and to serve this model, I'm using an image from Hugging Face called the text generation inference. And within that, I'm using a model which is Mistral AI, Mistral 7B Instruct. So this is one of the most recent open models from Mistral. This is a 7 billion parameter model. And what I do is I basically assign one GPU to this. Remember, I have two GPUs. So I am now assigning this model to one of the available GPUs. Of course, I mount the volume. So if you actually look at my volume, so this is called /data, and /data points to my host volume. I expose this as the load balancer endpoint. I give a static IP address because I want to access them through a well-known endpoint. So this is my static IP address. So let's go ahead and deploy the model through the LLM. So kubectl apply manifest llm.yaml. So now this is done, and when I come back and put the NVIDIA SMI command, which shows me the usage of my cluster, you'll actually see that the first GPU's utilization goes up. So it will go up to 23 GB or something, and it stops there, right? And if you look at the temperature, that is also increasing. It's 48 degrees, pretty hot. So I have 16 fans within the cabinet that is housing these GPUs. So we deployed the LLM, so that is done. Next, I'm going to deploy the embeddings model. Now, why do we need the embeddings model? Because we want to convert whatever text we want to search into a format that we can easily query and match the semantic context. Unfortunately, I don't have enough time to talk about embeddings model, but think of this as a helper model for the LLM, which is going to help the LLM retrieve what is required when we ask a query. So very similar to what I have done for the LLM, the embeddings model is based on a container called text embeddings inference, and I'm using one of the models from Beijing Academy of AI. It's an open model. So I'm going to deploy this. Now, as soon as I deploy, you'll actually see that my second GPU is going to go up, and it goes up to 25% maybe, and this is going to serve the embeddings model. So I definitely need both the LLM and the embeddings model to run on my machine. So once that is done, then I have to basically launch the vector database. So the vector database, in my case, is actually a Chroma database. So I'm going to use this. So I create a PV, I create a PVC, and I'm using an image to run Chroma, the most recent image. So let's deploy the Chroma database. Okay, now this is also running. Once that is done, I need to run storage. Storage is going to hold all the PDFs and unstructured data. And to make that happen, I'm actually using one of the popular object storage services on Kubernetes called Minio or Minio. Are you familiar with Minio? It's an S3 compatible object storage layer. So I am mounting this on my host machine, and I'm using one of the images, which is Minio latest. So I'm going to deploy this. So now the storage is also deployed. Now what I need to do is I have to connect the dots. So every time I upload a PDF to Minio, I want an event to trigger. It's almost like the connection between S3 Lambda and whatever destination you're using. So in my case, as soon as I upload a PDF to Minio, I want to trigger a webhook which will split it, calls the embeddings model, and puts the output in a vector database. So I wrote a custom webhook uh, which is basically responsible for that. So I'm going to deploy this webhook which will trigger every time I upload or delete a PDF from Minio. Now once that is done, I need to connect all the dots. So I need to make sure that my Minio bucket is connected to webhook and webhook is connected to my database. I need to bring all of them together. So what I'm going to do is I'm going to run this storage job. So if you look at the storage job, it's basically a run to completion job. So this is a job, not a pod. And it does a bunch of things. It basically calls this command line called MC, which is the Minio client. And it connects all the dots. It basically sets the, the put, delete, if you actually see. These lines connect my Minio bucket with the webhook. So I'm doing all the plumbing here. That's the responsibility of the job. And finally, with all of this in place, I can run the chatbot. So chatbot is what I built. It's my custom chatbot image. And this is ultimately available as a service at this IP address as a load balancer. So pretty straightforward. Now at this point, if you look at kubectl get deploy in my GenAI stack, you have all these components. Is that clear? And this maps to every component that you see here on the workflow. Right? So this is a microservices architecture running an end-to-end GenAI stack. So now we have this running, and similarly you can check the web services that are running. So these are the endpoints. Each of these deployment has a load balancer endpoint, and I have a very predictable set of static IP addresses assigned to this. Perfect. So now I can come to the browser and yeah, so everything looks good. Hopefully I should be able to hit this. Wow. Give me a second, I'm trying to figure out. So this is the risk or the fun of doing a live demo. There are too many moving parts. I know one is basically my VPN, and then I am SSHing into my remote lab. Lot of moving parts, so anything can go wrong anytime. I think I lost the connection. Yeah, so I'm going to disconnect and reconnect my VPN, and we should be able to continue. Yeah, so this is definitely a connectivity issue, as I can see. I'm able to ping. I can get this running, just a sec. Yeah, everything seems to be fine. I don't know why I can't access the endpoint. I seriously suspect, the firewall that is coming in my way. So I'm going to switch to my hotspot and reconnect. I always stick to my own hotspot to avoid any side effects, but let me connect again. This should be better. Sorry, just a couple of minutes and we should be able to get this running. Okay. Yeah, perfect. So as I suspected, the guest Wi-Fi of T-Hub has issues. Okay, so now we are here, okay, and this is the chatbot running on a Kubernetes cluster. You can actually see the IP address that is talking to my load balancer endpoint. And I basically ask a question, what is the excess baggage fee? So, like ChatGPT, if you ask what is the India score of a live match, ChatGPT cannot tell you, right? It will say my training cutoff date is whatever, 2023, January or whatever, and it doesn't respond. So very similar to that, Mistral doesn't have a context, so it cannot tell you anything about the excess baggage fee. Now what I'm going to do is, I'm going to play the role of a flight operations guy, the DevOps guy sitting in the flight IT center, and I'm going to copy the V1 of my baggage policy document. And the V1 policy document basically has this, right? So it is a PDF, and this PDF has information about excess baggage fee. I did this demo at KubeCon EU in March. That's why you will see everything in euros. So the excess baggage fee, if you carefully notice, is 25 euros per domestic, 20 for international. Oversized baggage fee is 45, right? So what I'm going to do is, I will use the Minivo client to drop the PDF into my bucket. Okay, now this is done. Now I come back to the chatbot and ask exactly the same question, right? Now, it actually comes back and tells you the exact answer, right? 25 euros. And this is coming from the PDF that we uploaded. Now let's also ask other questions like, the oversized baggage fee. What is the oversized baggage fee, right? So obviously it's going to respond with 45 euros per bag. Now again, you can see this. Now let's say this is running fine. After a few months, the flight operations team wants to change the baggage policy. So now they want to upload V2 document. Now V2 document has an increased baggage fee from 25 to 30 and 20 to 25. The oversized baggage fee is also 5 more euros extra. So what I'm going to do is, now I'm going to copy the V2 version of this baggage policy document to Minivo. So come on. Yeah, okay, this is done. Excellent. So now I don't even refresh my browser, right? I come back and ask exactly the same question. What is the excess baggage fee? And it actually picks up the most recent data, right? Now, this is the beauty of a GenAI powered chatbot. It picks up data instantly, and behind the scenes I'm using an event-driven RAG architecture. Now let's say someone jumped the gun, they actually uploaded this document before the approval came in, now they need to revert. So what is that we can do? We'll simply roll back and ask the same question again, and guess what? The chatbot is intelligent enough to roll back the response. And this is instant. This is where serverless and event-driven come into the picture, right? So that is how you basically perform an end-to-end end-to-end microservices enabled Gen AI application running entirely on Kubernetes. The data doesn't flow out of your cluster. And the entire stack, every component that you see runs as a microservice on the Kubernetes cluster. So this is a sneak peek of how the Gen AI stack would look like a few months from now. This is how customers are going to orchestrate Gen AI workloads through Kubernetes running inside their data center and on-prem environments. Right? So that concludes my demo. Do I have time for any questions? We are done? Okay. Thank you. I am around for Q&A.
Yeah, thank you so much for this insightful presentation. So can you please do that? I request Kapil to give away the memento. Have a huge round of applause once again for Janakiram.